Okay, so in the wave mechanical model, and we drew that yesterday, we had the image up there where you have your tiny nucleus, then you have a cloud of electrons outside the nucleus. So in that cloud, there are those rings or levels. So there's 7 levels inside the cloud. And then on the levels, there are these things called orbitals. Again, think of the levels like floors in a hotel, floors in a school. Orbitals are like rooms, classrooms, or rooms in a hotel. And that's where the electrons are found. So if you could, anyone see Ant-Man? Anybody else besides Sean? Ant-Man and Wasp or whatever, that's like the second
I haven't seen
sequel.
that new one. I saw the first
You saw
one.
the first one. So when they go quantum and they're like going in these weird places, this is kind of what they're talking about. They shrink down and they go inside this stuff. The reason I bring that up is if you could shrink yourself down, go quantum and go in here and look for electrons, it's kind of like in a school. Where would you go to find a student right now? You wouldn't look in the hallway, you would look in classrooms. You would, if you could shrink yourself down, you want to find an electron, you would go into orbitals. That's what this means. So that's the definition of the most current model. If this is all based on pretty complex math and probability, we don't get into any of that. You just need to know the name of it. Quantum mechanical, wave mechanical, or electron cloud. The electron cloud's fine to use. Everyone knows that. You can, tell me that and say that and use that term. But on a regents, they're going to use wave mechanical or quantum mechanical. So I'll say it enough where it'll stick, but that's the current model. And these are the big deal now, orbitals. Okay? So the highest probability of finding an electron is inside an orbital, and the orbitals are on those energy levels. All right? So that is, that's it. That's all we need to know about the most current model, kind of the shape and what it looks like, sort of, and then these things called orbitals. All right? Questions with that? So I'm going to leave these alone for now, this stuff, and then we're going to talk about radius, and then we will come back to this. Our next 2 labs, one lab is we're going to actually kind of create an image that looks like the electron cloud, and then the lab after that we're talking about electron configurations in orbitals. So we'll do that after. Hopefully we can get to that before break. Time goes very quickly. It's the 5th, but we'll be here before we know it. All right.
New monitor?
Yeah, my other one was the letters were, it was like kind of fuzzy, and then everything had like mini shadows, and it was like making me crazy. Like, am I seeing that, or is that happening? And it was just, so I think it was starting to go.
When's break this year? Isn't it like the 22nd?
21st is the last day.
So when? Do we get the whole week of New Year's
The
off? Or do we come
2nd or
back?
3rd we come back. One of the
Okay.
two.
Third.
I think it's the 3rd.
Is
Yeah.
it the 3rd?
So 21st or 3rd is pretty good.
It's
But
like 14.
yeah, all right. Actually, I have a doctor's appointment for my uncle. I have to go with him on the 21st, and I just remembered this since we're talking about it at 10:30. So I'm gonna miss this class, and then I'm coming back after the appointment. But day before break, it's okay. I guess I'm not probably doing a whole bunch of movie. I'll give you a test.
Yeah, movie.
All right. So here we go. Now, all right. I'm going to use you guys again as an example. So let's do this. 1, 2, 3, 4. Yeah, 4, go stand over there. And then 1, 2, 3, 4, go stand over near the apples. Now, usually I have a big rope that we're going to play tug of war with, but I haven't grabbed it yet. So I gotta do that. All right, you 4 have to get closer together over here. You don't have to like touch each other. Okay, stand right here. Stand next to her. Get in a line, straight line. Okay, you guys kind of clump up. Okay.
Are they the nucleus? Or are they the energy levels?
You won't show it. You're right.
I would show this, but I'm not supposed to record you guys without like parental consent, so I don't need that business. All right. Okay. Hold that, Zeke.
Look at his baby.
Okay. It's 12 feet. It's good enough.
They're 24 feet, so it's a big thing.
Yeah, I mean, I have a.
25 feet, sorry.
Okay, alright, this is 10 feet. Now, if they are protons, and these guys are electrons, who are we?
Wait, we're what?
Protons.
Aren't we?
Yeah, feet, right, okay, alright, good. Now, so, if this is the distance of the radius, what's radius mean?
Like the half, like.
Yeah, so if you have a circle,
It's just like another
and you
one.
measure the diameter, let's say, and then cut that in half, that's the radius, right? That's that one way to think of it? The diameter of a circle cut in half is radius? Okay, good. So, keep it, there you go. Okay, so we got 10 feet, all right? Now, why don't you two stand up, please? Come on over. Now, U4 are electrons, U4 are positive protons, your negative electrons. What's the charge right now? Neutral. Okay, now you two are electrons. Add on. We're adding 2 electrons. We become -2 and almost out. What happens to our radius? Why does it get bigger? More electrons. Good. Okay. You guys can sit down. You can sit down. And you can sit down. Now what's our charge?
+2.
+2. Why?
Because there's 2 more protons than there are electrons.
Good. What happened to our radius?
It got smaller.
It got smaller. Why?
Because there's like less electrons.
Less electrons. Does this make perfect sense?
Yeah.
Okay, sit down. Thanks. Tomorrow, I'll try and get the rope today at some point. And tomorrow, we can actually play tug of war. Since Sean says I win, we'll just put the entire class against Sean. All right.
I'd win.
So here's the concept for atomic and ionic radius. So atomic radius. So if we think of atoms as like spheres, right, or circles on paper, right? Measure the diameter. Half of it is the radius. Okay. So atomic radius, and then ionic radius is how does the radius change when it becomes an ion? So I just showed you a very simple example. All right, I was going to have you hold the positive negatives, but I think you guys can just kind of, I think you get it. So I'm going to just kind of teach you the general concepts here. I have, must be in the back, I have a poster I'll have one of you help me hold up, and you can see there's a trend in radius on the periodic table, but the periodic table is all atoms. What we just talked about was ions, so we'll do that after. Who can summarize? What did we just learn? And we use beryllium, but we can use any element.
The more the electrons, the bigger the radius gets.
So, right, so if we add electrons, the radius increases. And what about if we take electrons away?
The radius decreases.
Decreases, right, very good. So, here's what we're going to write. In general, what do you call the positive ions?
And cations.
Cations, right, they're positive. In general, cations are smaller than atoms, right? Cations have lost electrons, so they are smaller, so their radius shrinks. And anions, those are negative, are larger than atoms. And there's a lot of different ways to ask these questions. So, I say in general because there's always, things are not necessarily always black and white. There's gray area here. But let me give you some examples that we just talked about. So if we say, all right, calcium versus calcium plus 2. I want to know who has a larger radius and who has a smaller radius. And again, radius means we're thinking of the atom as like a sphere or a circle. So if you take the diameter and then cut that in half, so there's our radius. So basically, we can think of it this way, is it this one's big and this one's small, or is it the other way around? Is this one that size and then this one's bigger? So that's how I want you to kind of visualize this. Think of a circle, think of a sphere. Well, when they lose or gain electrons, that sphere is going to get bigger or smaller, and that's what I want you to kind of visualize. All right, and that's what I mean by radius. Okay, so what do you guys think? Ca or Ca plus 2? Who's larger? Who's smaller? Ca is going to be larger, so this one is larger radius. This is smaller. because Ca plus 2
Is losing one.
lost 2 electrons. Here's how you can prove that. What's the electron configuration of Ca?
2882.
2882. How many energy levels does it have? 4. 1, 2, 3, 4. So it would have, so Ca would look like this. 1, 2, 3, 4. That would be Ca. And it would be 2, 8, 8, 2. What's this configuration? 288. So again, imagine we had like a mini tape measure. A little tape measure. And you measured this, okay? Just simply measuring the numbers on the board, which is not what's going on, but from here to here, it takes up more space than here to here. So it's the same exact concept. Ca plus 2, I would actually erase this entire 4th level. It only has 3 energy levels. So think of an onion. If you take the outer layer off, it's going to be smaller. If you keep peeling layers, it gets smaller and smaller. So this should hopefully make perfect sense to you guys, that when atoms lose electrons and become cations, the cations get smaller. Make sense?
Yeah.
Questions? Okay. Let's take an anion example. Let's go with, we'll do Cl. Cl versus Cl minus 1. This one's a little harder to understand. But I showed you with you guys, I had you sit, stand up, sit down. And that, what I showed you, is a good way to visualize or think about it. So, what did we learn? When I had Reagan and Amanda stand up, what happened to the radius? It increased. So, based on that analogy and that example, what do I have right here? Who's larger, who's smaller? This is larger. Larger, bigger, whatever you want to write there. This is smaller. That is correct. But if you're following me here, why is this one harder to explain?
It's because it's got a negative, I think it's, I don't even know.
Not that. Not think of it. How did we explain? Let me ask it a different way. How did we explain Ca is larger than Ca plus 2? What did I write underneath that? The electron configuration, right? So why was Ca larger than Ca plus 2?
Oh, it has a larger electron.
It lost 2 electrons, right? And how many energy levels does Ca have? 4. How many does Ca plus 2 have? 3. 4 is bigger than 3. That makes sense to everybody, right? Why can't I use that same explanation here?
Oh, because it doesn't lose or gain one.
Right, it doesn't lose or gain an energy level. So Cl is 287. What's Cl minus? 288. So the same number of levels. So if I'm drawing the picture, here's my 1, 2, 3. Whether it's 287 or 288, that picture doesn't change. This is where I wish I had the rope today. I apologize I didn't have it because it would help. We could use it right now and it would really help you understand, but it's all right. I'll bring it in tomorrow. I'll do it tomorrow. So, what's the deal? How come electrons don't just whiz off into space? Why do they stay in the atom?
Just the charge, the nucleus is
The nucleus is attracted and nucleus is pulling them. Okay, positive protons pulling negative electrons. Okay, so use the tug of war analogy. If I'm playing tug of war against one other person versus 10 other people, which scenario? Me against one person, me against 10 people. Which scenario do you think I'll be able to pull the people closer to me? One person or 10? One. It'd be easier. Maybe I wouldn't, right? Maybe if I'm playing tug of war against, I don't know. John Cena, it's one-on-one, he's going to pull me through the wall, okay? So, but the point is, if there's 10 people, it's going to be harder than one person. You agree?
10 jobs.
Okay, so, how many protons does Cl have? Anybody?
17.
17. Over here, I want you to put plus 17. Cl minus still has 17 protons. Use the tug of war analogy. Why is this one larger? the protons are pulling. So the 17 are pulling. Why is this one slightly larger?
Has more, less people.
There's one more person here making it harder for the nucleus to pull, so these electrons actually start to win the battle going the other way. This one, because there's one less, it's slightly easier. So when you have the same number of protons, but the electrons change, it's like adding or taking away a person when you're playing tug of war. So it is kind of hard to visualize. That's why I like to get the rope out. All right. Obviously we're done. So don't forget to do this. You know what? Do this side. Just do this. Just this side. This side is on radius. You're going to do this and the back of the other one. They're both going to be due prior. So just do the front.